So let's talk about the land scaling. So land also follows this exponential law, like Moore's law for the scaling of the minimal feature size. And in the 2013 or 14, the two-dimensional land scaling approaches the limit around like 15 nanometer node. And actually, NAND flash scaling is more aggressive than the DRAM or the logic transistor. And then the industry make a transition from two-dimensional NAND to three-dimensional NAND. And today, if you buy the SSD from the market, probably is 3D NAND. And 3D NAND actually has larger feature size. We will discuss that in a minute. What is 3D NAND? So the 3D NAND will equivalently scale the density of the NAND. And actually, you can buy those 3D NAND flash products from many vendors today, like Samsung, Western Digital, Toshiba, Intel Micron, SK Hynix. So this is the mainstream technology for your SSD. So what is a 3D NAND flash? This is a circuit schematic for the three-dimensional NAND. And you see this is a really three-dimensional circuit. And this is one string of the NAND string. This is a string. And you have seen this string in two-dimensional space, like we show here. So this is a conventional two-dimensional NAND flash. So you have word line and bit lines, but they are on the horizontal plane. So for the vertical line, you are going to tilt this by 90 degrees. You are going to make the one plane like vertically, and you are going to have many planes like this. So equivalently, this transistor will occupy a very small space because those transistors are built vertically. And here, if this is your substrate, those transistors are standing up. Normally, you know, the transistor when you build is along the surface of the silicon wafer horizontally. But this one, the transistor is standing up like this. So equivalently, you are going to scale the space. Let's say if each string occupies 2f by 2f space, f is your feature size, minimal size. So each string will occupy 4f squared. And if you have n layers, you are going to reduce the effective area for one floating gate transistor by this number of n. And today, what is the number of n you can buy from the market? N nowadays is 128. You can buy 128 layer SSD from the market these days. So you see how aggressive the scaling is. Effectively, you can make this 4x squared divided by 128. And also, the 3D NAND is typically equipped with multi-level cell. You can have 2 bits per cell. Then equivalently, let's say the area per bit equals to this 4f squared divided by n, and then can be divided by 2. This 2 is 4, let's say if it's 2 bits per cell. So you say this is a way to reduce the area per bit, or in other words, increase the density. So that's why today you can easily buy like 128, 256 gigabyte SSD with like dozens of dollars. This is how you achieve the high density. You reduce the cost per bit. And this is just an image for reverse engineering. So this ChipWorks is a company to buy the products and then cut the chips and look at the chips under the microscope. So here is a cross-sectional view of the 3D NAND. This is the first generation of the 3D NAND from Samsung, I think. And this is horizontal side view of the chip. And you see so many layers here. And here is one string of the NAND string. And also, this is the first chip from Samsung Like in 2014, this is the first 3D NAND commercial chip, and at that time it's 24 layers. So this is a chip, and you see this plane is just the 3D NAND array, and the peripheral circuits, you have the row decoder and the buffer and the peripheral circuits as the edge of the array. So this is just an example of the chip. And at that time, it's only 24 layers. And as I just mentioned, today it's becoming like 128 layers. I think Samsung has 6 generations of the 3D NAND technology, because each year they announced one new generation, and from 2014 to 2020 they already have 6 generations, and it increases the number of layers from 24 to 128 today. So this is how you increase the density. That means you are going to have the same horizontal chip area, but you are going to stack more and more transistors vertically. That means the same cost, you are going to have more transistors, more bits, then you can reduce the price for your SSD. All right, any questions here? If no, then that's end of the NAND Flash